So we are going to start our new unit, which is the exponential functions. Okay, so we're moving out of quadratic, we're moving into exponential. So it's a totally different kind of functions. We're not dealing with parabolas anymore. Okay, so we're gonna start with exponent's law. We're gonna explore exponent's law. We're gonna explore what happens when I have, let's say, two terms with the same base and they're multiplied, what's going to happen to their exponent. Okay? So the first thing we're going to do, so there's multiple exponents now that we're going to look at, and then we're going to have to use all these laws in combination. Okay? So pay attention to this. Knowing the laws is very important, and then as you can see, those are also here on this wall. Okay, you have different, all of them, or most of them that you guys use in this class. They are on this wall with some examples. Okay? So let's start with, what is it? What's the law? What do I need to have? And all of these things. So the first thing that I want to explain to you guys is when I have an exponent, right? I have two things. When I have a term, I have the base, I have the exponent. Okay? So we call this the base, and whatever is the power, that's your exponent or your power or whatever you want to call, like there's multiple names for it, but we're going to call it exponent. Okay? Base and the exponent. Are we okay with that? Yeah. Okay. Now, the first thing that we're going to look at is what we call the multiplication law. Okay? Why is it called multiplication law? It's because I have two terms and they're multiplied. So you can see that the two terms are multiplied. So I have a to the power of 4 times a to the power of 5. So if I take a to the power of 4 and I want to expand it, a to the power of 4 is a times a times a times a. That's what gives me a to the power of 4, right? So a to the power of 4 is a times a times a times a. Now it's multiplied, so this is where my multiplication comes. So let me just do this 1 second. So if you look here, I did the a to the power of 4, right? That's the green one. Then what I'm going to do is I'm going to write another multiplication because I have that multiplication. And then a to the power of 5 means a times a times a times a times a 5 times. Okay? So this is my expanded format. So if you look at this, how many a's are multiplied together? 9. So I can simplify this as a to the power of 9. Okay? So let's try the next one. If I have a to the power of 2 times a to the power of 4. What's a to the power of 2 in expanded format? A times a. Okay? Now I have times, right? So I'm going to have to write that times. And I have a to the power of 4. So then I have to write a times a times a times a. So if you look here, how many a's are multiplied together? 6. So that's a to the power of 6. Okay? So moving on to the next one. I have a to the power of 5 times a. How would I expand that? How would I write that in expanded format? Yeah. So for the first one, I would write a times a times a times a times a. Right? And then I'm going to have to write that multiplication. And then just one a by itself, so that's going to be a, right? And then that shows me that I have 6 a's multiplied together. Okay? So moving on to the next one, I have a to the power of 6. So that's 6 a's. 4, 5, 6 multiplied by, and then I have a squared, so that's a times a. So that shows me that I have 8 a's multiplied together, so that's a to the power of 8. Have you seen any trend here? Have you seen anything happen?
Yeah.
What do you see?
That when you
So-
have the same base, you just add the exponent.
So if you look at this, I have a squared times a4, I'm getting a to the power of 6. If I have a5 times a, I'm getting a to the power of 6. If I have a6 times a squared, I'm getting a to the power of 8. So if I'm going to give a good guess for this one, it's going to be a, and then 4 and 3, that's 7. So my answer is going to be a to the power of 7, right? Let's see if that's the case. If I have a times a times a times a, right? And I have times, and then a cubed. So that's a times a times a. I have 1, 2, 3, 4, 5, 6, 7. So I have 7 a's multiplied together. I did guess it right. So what's happening here is because the multiplication is repeating, and then you're multiplying by another repeating multiplication, right? The number of terms are adding up. Okay? So what I'm doing here, number one, I have to make sure that I have the same base. If I don't have the same base, it doesn't work. Okay? I keep my base, and I add my exponent. That's whenever I have multiplication. Okay? So the rule is, if you have multiplication, then you're going to keep the like base. Okay, so in this case, my like base is a, and I'm going to add the exponents. So no matter what my exponents are, right, as long as I have the same base, so let's say if I have a to the power of m times a to the power of n, that's my general formula, right? I have the same base. What would be my answer for this? A-M-N or A-M plus N?
A-M plus N.
Okay, plus.
So I have a to the power of m times a to the power of n. I'm going to keep the like base, which is a. What do I do with my exponent? So it's m plus n. No matter what m, n, a is, right, it's going to be the same. Right? We call this the multiplication law. Okay? So, here's another example. If you have b to the power of 7 times b to the power of 4, what do you get? What's my base? B. So I can keep it. And then what do I do with the exponent? So 7 plus 4 is 11. So that's b to the power of 11. Okay? As long as you have the same base. So another example. In this case, I have 2 to the power of 6 times 2 to the power of 3. What do I do? Which is what? What's my base? 2. So I keep my base of 2 and then add the exponent. So that's 6 plus 3, which gives me 9. So I'm keeping my base. I don't change it. And then I raise it to the power of the sum of the exponents. Are we okay with that? So this is called the multiplication law. Okay? Now let's look at what happens if I have a division law. So if I, instead of multiplying, I'm dividing. So same thing we're going to do. We're going to expand. Okay? We're going to look at it as an expanded format. So I have a to the power of 5 divided by a to the power of 4. Okay? Eyes on me for a second, please. So what I did on the numerator, I wrote a times a times a times a times a 5 times. On the denominator, I wrote a times a times a times a. So if I'm going to simplify this, because I have that division, right, I can just literally cross them out. Because when I have something divided by itself, they simplify, right? Cross, 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 cross. What do I have left? Just a. Okay? That's power of 1. If I write a, that's the same thing as to the power of 1. Okay? So let's look at what happens if I have a to the power of 4 divided by a to the power of 2. So I'm going to take a to the power of 4 and I'm going to write a times a times a times a divided by a to the power of 2. So I have 2 a's multiplied together. Now what do I do because there's division?
Cross them out.
I simplify, I cross them out. So 1 and then the second. So what do I have left?
I mean, a to the power of 2.
A to the power of 2 because I have a times a. So that's a to the power of 2. Do you see that? Okay. Now let's try it with the next one. So a to the power of 5 divided by a. So I have a times a times a times a times a divided by just a. Simplify, cancel, cancel. That's it. I have nothing else in the denominator. So how many a's do I have left in the numerator?
4.
So that's a to the power of 4. Did you catch on the trend yet? What is it? What's happening?
Same base, subtract the exponent.
Subtract the exponent. So if I take 5 minus 4, that gives me 1. If I take 4 minus 2, that gives me 2.
But it's not, but it's 5.
Which one? This one?
Yeah.
5 minus 1 is?
You're subtracting
5 minus 1 is?
in division. In multiplication, you have.
Is 4. Right? So what do you think the answer is going to be for the next one?
A to the power of 4.
A to the power of
Opposite.
4. In the division, you're going to subtract your exponents.
Okay, so you're subtracting the exponents and then you're okay.
Okay. So let's look at this. Let's look at this one and see if that's what we're going to get. So I have a times a times a times a times a. So that's 5. And then one more. Divided by a times a. 1, 2. What do I have left? 1, 2, 3, 4 a's multiplied together, so that's a to the power of 4.
You know why I got confused? Because you only wrote 4 A's, not 5.
For which one? No, I wrote 5. It's a small a right here that you did not see. There you go. Better?
Yeah.
Okay. What do you think the answer for the last one is going to be? A
A.
to the power of 1, which is just a, right? I don't have to actually, like, you can write the power of 1, but you don't need to write it. Okay? So, division law says, keep
In the base and subtract the exponent.
the like base and subtract the exponents. Okay? So if I have a to the power of m divided by a to the power of n, I keep my base, which is, and then what do I do with my exponent? M minus n. Okay. So if I want to give you another example here, so let's look at, for example, if I have x to the power of 9 divided by x to the power of 2, what would your answer be? X to the power of 7, because I'm taking 9 and subtracting 2 from it, right? What if I have this? 10 to the power of 6 over 10 to the power of 2. So you see how, in this case, division can be written in two different ways. It can be written as an actual like division, you know, this is divided by this, or I can write it as a fraction. It's the same thing. All right? So again, I'm subtracting my exponent. I leave my base, so that's 10. subtract 6 minus 2, so that would be 4. Are we good with that? Excellent. So far we have 2 laws down. Let's look at the third. Moving on to the third law, which is the power of a power law. Okay? So that means I am powering twice. I have the same base, right? So you see here I have only one base, which is A. And I have a to the power of 4, then to the power of 5. Okay? So I'm powering the same base twice.
So you're adding.
So let's see what happens here. If I have a to the power of 4 to the power of 5, that means I have a to the power of 4 multiplied by each other 5 times. Right? So I take a to the power of 4 and I multiply it by itself 5 times. Now if I have multiplication, what do we do with the exponent? If you go, add them. So if I add 4 plus 4 is plus 4, plus 4, plus 4. So I have a to the power of 20. Okay? What do I write for this one? A to the power of 2. So times a to the power of 2, yep, times a to the power of 2. So I'm multiplying that base, which is a to the power of 2, 3 times by itself. So if I want to use my multiplication law, which says add the exponent, that would be 2 plus 2 plus 2, which is
6.
So that's a to the power of 6. What would you do for the next one? Yeah, a to the power of 5. So times a to the power of 5, which is a to the power of 10. Okay, can I have your attention here for a second? What's 5 times 2? What's 2 times 3? What's 4 times 5? So you see what's happening here? Right? When you have power to the power, the exponents are being multiplied. Okay? So if I have this, it's a to the power of 6 times a to the power of 6 times a to the power of 6, which is a to the power of 18. Right? Because 6 plus 6 is 12, plus 6 is 18. At the same time, if I go to this, 6 times 3 is 18. What would be the answer for the last one?
A to the power of 3.
Yeah?
Now 4 3s are 12. 8,
A to the power of
12.
12. Because a
And
4 times a 4 times a 4. So, in this case, I'm going to keep the base, right? There's only one base, and I'm going to keep it.
multiply it.
Yeah. Yep. So if I have a to the power of m to the power of n, I keep my base, which is a, and I multiply my exponent, so that's m times n. Are we okay with that? Okay, so here's what I want you to do. I want you to try these questions. Let's see what you can get done. When I come back, I'll come back and we'll take them up. Okay?